So, this is CSIS 45, the Thursday section, 11:20 to 12:45. So, one new thing on the homepage that I added, or actually two new things for this class, I got to add it to the other classes too, is office hours. If you click on this link here, you're going to see my office hours for the semester. It looks like this, right? And all the stuff in green, these are my office hours. It's in BU 123, which is that door next to the exit, right in front of the guy's restroom. So that's where I'm at. Come find me. Also send me emails if you have any questions. Tutors, there's a link in there to this webpage, which is the STEM Center, which is in MA 102. They're open up every day, Monday through Thursday, 8:30 through 5, 8:30 through 3 on Friday. They're going to have somebody who supposedly has a degree in computer science there, and that person should be able to help you. But I should be your number one resource, so come to me. Don't be afraid. But if you want someone else, there's also going to be Marisol sometime this week. Hopefully, I'm going to get her scheduled to post here. So there's going to be another tutor to help you out during the semester, and so that's the new and exciting. So we already went through week 1, where I showed you how to install different things, how to get the things going on your computer, and the basic introductory information. We had 2, 4, 6, 7 different assignments and a couple of extra credits. So this class has more assignments than the Python class and the Java class, just so you know. They're not a whole lot more complicated, there's just more of them. So let me have a look at the lecture notes that I had for you last time so that I can start with that. And that's something else. Okay, so I'm going to zoom in on this little thing here, and we're going to go over all the stuff that I went with you last time. All right, so comments in C++ are anything that starts with 2 forward slashes, just like with Java, and just like with every one of my other classes. You got to have these comments on top. Program number, your name, when you started this thing, the description of the program is supposed to do. You can copy paste the description from the assignment itself and just paste it in there. This is worth 30% of your grade. And again, comments are not really part of your code. They're just an explanation for what the code is doing. For other people who are going to read your code, mainly yourself, because you're the one who's going to be reading these things, hopefully. When the semester is over, you want to review how you do this in this language. Go back to your first programs, review what's what and how you do things, and that's why we have comments. Okay, the minimal amount of comments are the ones on top and the ones on the bottom, multi-line comments that show how the program ran. Okay, everything else, all these other extra comments that you have in there are optional. They're good if you want to explain yourself how things are working. I highly encourage that in the beginning of the semester. Write a lot of comments. Okay, the more you type up and explain to yourself how things work, the better you're going to retain this information. All right, so the starting piece or template or whatever you want to call it for every program is these lines here. You need to have an include IOStream, you need to have using namespace std, and you need to have an int main with curly brackets in it. Okay? Curly brackets, curly brackets. Okay? What I'm reading this in right now is Sublime Text Editor, and I think I did my code in CLion last time. I'm pretty sure I did. So this is CLion. If you haven't got this yet, there's instructions on how to set up CLion on Windows. If you still don't know how to do it, come and see me. I'll help you out, or send me emails. Increase font size. Okay. So what I'm going to do is I'm just going to read this, and well, now I'm going to copy paste this in C line. There you go. Okay. And let me just try to see if I can collapse it. Yeah, there you go. So these are the main parts of your every program. Include IOStream using namespace std, int main with curly brackets, and then whatever you're going to write is in there for now. Okay, so what else did we cover? Output. What is output? Information comes out of the program. In C++, you do output using cout. Cout, less than, right? And then some text is, if you want to show the text that's in quotes, that's the text that's going to show. If you have less than andl at the end of your cout, that is going to insert a new line automatically. So for example, if I have cout world here, okay, hello, and then world, and then I'm going to erase, well, I'm going to leave it there. If I run it, oops, forgot my semicolon, run again. Okay, so notice what it does. It says hello, and there's world on the next line, and then there's some other word, age, whatever that is later on, this other cout. The age shows up on the same line. So if you don't want it to, you have to go in there and you have to insert a new line, andl. Okay, and you run the program, and then age shows up on the new line. Okay, so that's the purpose of an andl. You can either do andl, or you can do \n. Right? \n is the same thing as an andl. Insert a new line, same as \n. Right? So if I run the program again, works the same way. Okay, same but different. So that's that. And so this was basically how we show one type of information, which is actually text. Anything in quotes is a string or text. Other than text, our programs can have whole numbers, decimal numbers, characters. There's also arrays and vectors and different other things, but we'll keep it simple for now. A whole number is called an integer. The decimal numbers can be either float or double. Double is just a decimal number that has twice as many digits as the float. So if you want really the largest possible number you can represent, you use a float. If it's a smaller decimal, you use a float. If it's a really big decimal, you use a double. Smaller decimals, you use a float. Characters in C++ or anything in single quotes. And text in C++, just like in Java, is anything in double quotes, just like Python too. Okay? These kinds of different information, and by the way, I'm just reviewing last week, are stored in our program using variables. So the way we store information into our program is using variables. What are variables? Variables are just words we make up to store this information. Okay? Unlike Python, you have to declare the data type in advance for your variables before you can use a variable. So for example, in Python, I would just do age, and it knows what age is by default. If I say age is equal to 10, it knows it's an integer. If I say age is equal to 3.14, it knows it's a decimal number. Okay? In C++, you have to specify, you have to be clear about what's the data type before you declare your variable name. Okay, so here I am declaring variables, which means I'm telling the program there's going to exist this word age, and this age word is going to refer to an integer value which is going to be stored someplace in memory. Okay, unlike a lot of the other languages like Python that we did, if you've done that, C++ allows you to really dig deep in the hardware level. So it allows you to do low-level things like you can actually look at the memory address of a variable, and you can have pointers and all kinds of other fancy things. But let's not go there. So the bottom line is these variable names that I have here are just referring to some magic number in memory where information is stored. Okay? And so this one is an integer, which is a whole number. Float is a decimal. Double is another decimal. Char, character. You also have string, and that's about it for now. Okay. These variable names that you see here, age, weight, letter, text, first name, are pretty arbitrary. I can choose whatever variable name I want as long as it does not violate some of these rules here. And those rules were, can't start with a number, right? Can't have a number in the beginning. You could have a number in the middle. You could have a number at the end, no problem. Okay, just don't start the variable name with a number. You can't have spaces. So if I have a variable called first name, I can't have first space name because then it will think it's two separate things. You can't have any special characters such as any of these and others, right? The only special character that you're allowed to use in your variable names is underscore. Underscore is okay. So there's two naming conventions for your variables. There's this mixed letter notation, which is you basically capitalize every first letter of every subsequent word, or you can do underscore and then connect the different words that way. Both are widely used. There is no better one, right? It's just one or the other. I sometimes mix them. It's good for you to kind of keep it consistent, stay with the same convention throughout your programs, but I don't really follow that rule. Sometimes I get bored and I start mixing them up. Okay. Can't use reserved words. So these things in orange, like int, float, double, char, main, a few other ones like include, using, namespace, right? There's a few words that have special meaning in the C++ language. You cannot use those words for variable names. Okay. Unlike Python, where you could use those words and then your program is going to stop working, C++ is a lot stricter, and it prevents you from doing some stupid things, okay? But then it allows you to do all kinds of other stupid things. So, and then use meaningful variable names, okay? If you're going to have, one variable which is going to hold the information for age, call it age. Don't call it num1. If you have another variable which is going to hold the information for weight, call it weight. Don't call it num2. Because if you have a whole bunch of similar sounding variables, it'll be hard for you to figure out what variable is doing what in your program. It'll be hard for you to figure out how the program is working, why it's doing things. So meaningful variable names. So these are the rules of the variables. There's no restriction on how long your variable could be, so you can go crazy, make it very, very long. Don't do that. It's bad practice. Generally speaking, your program, what you're seeing on the screen, should be no more than 80 characters, right? If it exceeds 80 character limit within the screen, don't have something that scrolls off the page and you have to kind of scroll and figure out, oh, what's the rest of this stuff, right? Just like when you're reading a magazine or or newspaper or whatever it is, the articles are in short little paragraphs, narrow paragraphs, because it's easier to read them that way. You don't have something that stretches on the whole page. Okay, so that's one thing. For readability, all right, so then variable names, data types. The data types are different types of information. The variable names I went over right now. And this here is declaring these variables. So I'm just telling the program there's going to be these different words that are going to have a special meaning for my program and what kind of information I'm going to store in them. That's declaring a variable, okay? That's important terminology because you're going to have some error messages that are going to pop up and then it's going to tell you undeclared first user of identifier or something like that. Means you didn't declare your variable. Okay, if you know what declaring a variable is, then you know what this means, right? So this here is declare variable age to be of the integer type. Okay, same thing what we're doing with the other ones too, just declaring variables. Okay, then we also have initialization of variables, right? Giving variables initial values, and the reason that I did this cout right here is to show you what the initial value of age is. Fortunately for us, this time it turned out to be 0. Last time I was doing this, you probably noticed that age kind of changed its value. It was some big number. And the moral of the story is, actually it was this number right here. It was number 32767. So don't expect C++ to make your variables equal to 0 as soon as you do this. So as soon as you're declaring a variable, that variable refers to some place in memory. There's might be some number stored in that place in memory, and whatever's stored in memory, that's what that variable is going to be equal to. So when I ran the program last time, it was equal to this, 3276. Okay, when I'm running it this time, it's equal to 0. So don't expect it to be equal to 0 unless you initialize it to 0. If I go in there and I do this, then it will be equal to 0. Okay, but if I don't, then it could be any kind of a magic garbage number in there. Okay. So initializing variables, you can initialize a variable at the same line as you're declaring it, like so, right? That's fine. Or you can do it on separate lines, like I'm doing right here. So giving initial values for these variables is actually really important for C++ because the values that are stored by default in the variables are garbage. Okay? So that's initializing, declaring, and then when I went over input. Input is information that goes into the program, right? How we do input in Python using cin, greater than, and then the variable name. Okay, that's it. It's actually kind of neater than Java. Okay, maybe not as neat as as Python, but whatever. So right here on the bottom is where my program runs in CLion. It's waiting for me to enter information. So the program hasn't ended. It's kind of like hanging in there, waiting for me to do something. Well, what is it waiting for me to do? Enter some kind of a number. Okay, so if I enter a number and I hit the enter key, then that number, as soon as I hit the enter key, gets stored into this variable age. And then right after that, I show you entered age, and then it shows me the value of the variable that I entered. So you want to have, you want to show yourself the variables or the information that you entered into the variables so that you ensure that your program is working the way you want it to work. Okay, a lot of times you're going to enter information. Let's say I'm entering 3.14, but I'm entering it into an integer variable. Well, it's going to cut off the decimal piece, and then later on when I try to do some kind of a math with it, it's not going to work the right way. The only way for me to show myself this as early as possible is to just do some kind of an output of this variable as soon as I entered it. Okay? This here, enter a new integer, right? This message that we're telling to the user right here, like this piece right here, is called the prompt. Okay, if I take this out and I just run my program, then it's just going to hang in there and you don't know what's happening. Am I supposed to enter something? Is this thing frozen on me? What am I supposed to do? Right? So unless you give the user a meaningful prompt, which is the message that tells them what to do, then they're not going to know what to do. Okay? And different kinds of inputs. Input of an integer is the same as input for a double. It's the same as input for a letter. And strings in C++ are not as easily entered as in other languages. So I'm kind of leaving them out for now. Another thing that I covered was the integer arithmetic. So if you have one integer, one whole number divided by another whole number, right? Normally what's 3 divided by 4 is 0.75. Okay? Well, if you do 3 divided by 4, you're going to see that this thing is actually going to show you 0. Okay? So if I run the program, it's going to ask me to enter a bunch of stuff. So all right, age, weight, letter L, right? Then you're going to see that this right here, 3 divided by 4 is a 0. So this piece of code right here shows you a 0. And this other one underneath it, 3.0 divided by 4.0, shows you a 0.75. Okay? So if you want this thing to do the math as it should, don't work with just integers, okay? Because it could mess up your equations. This is not something that exists in Python, but it exists in Java, it exists in C++, it exists in C. Java is, built on C basically, C++, same standard. Another thing that I mentioned to you last time was what's a bit, right? Bit is the smallest piece of information that you can store in memory, right? It's either 0 or 1, that's a bit, okay? It's using the binary numbers, 1 and 0, to really represent a state in your circuitry. It's either something's on, it's either electricity is flowing through it, or it's off, and electricity is not flowing through it. Okay, and those two states of on and off, we find easier to represent using the binary numbers. And what's a binary number system? Well, it has just 2 digits, 0 and 1. What's our decimal number system? It has 10 digits, 0 through 9. Okay, so how do you represent binary to decimal? And there's an assignment in this, maybe this week, maybe next week. Okay, it basically, you just combine a bunch of 1s and 0s. Right, so if you have a single 0, that's a decimal 0. If you have a single 1, that's a decimal 1. If you're trying to make 2, then you need 2 binary digits, right? So the decimal 2 is 1 0, the decimal 3 is 1 1, and etc. 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 If you want to have like a number as big as 256 or 255, right? That's the biggest number that you can. The biggest decimal number that you can represent with 8 bits is 255. So if you have a 1 1 1 1 1 1 8 ones in binary, then that's the same as saying 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. That adds up to 255. Okay? So now you know. So that's bytes and bits, right? And then there's also megabyte, gigabyte, kilobyte, all that good stuff. And that was pretty much all I covered last week, plus some hints on a couple of the assignments, P2, 3, 4, and yeah. And then also multi-line comments at the bottom of your code. Show me how your program ran. If this is not here, I'm taking off at least 30% off the grade of that assignment. Okay, I don't have time to test all your programs. I got 250 students, so you gotta help me out. Also, I'm the customer, and you know, I require this from you. If you don't do this programming work, you don't get paid. Okay, so I want a working product, so test your product before you give it to me. That's how you show this to me. Multi-line comments at the bottom of your code. Okay, so this is the review of first week. And let's have a look if I have anything else in there. Yeah, that's that. Okay, and then all the lectures and the videos are posted. This is the lecture from Monday. This is the lecture from Thursday. Okay, this week, if you're one of the Monday people watching this video, you are still going to have to do these assignments. I don't care if Monday was Labor Day. Tough luck. Okay? So there's 4 different sections. One of them did not have an actual class on Monday. They can watch this video, they can follow everything that I said, and then complete everything for week 2. Okay, and if they don't, they're going to be behind. I will cover this lecture for the Monday people again, and I'm going to do the week 3 also at the same time, but it will be a little shorter. So, what are we going to do about for week 2? So week 2, I already told you input, outputs, data types, right? Variables. That was week 1. Week 2, we're starting to talk about selection. And selection is how we're going to make our programs seem intelligent so that it can decide between different things. These decisions are going to be done using these reserved words: if, else, and, or. Okay? So, before I get into that, there's a little link in there for processing, and it basically tells you that processing is kind of like a general term that refers to logic and addition and subtraction, looping, repeating things. Okay? Processing is done with the arithmetic logic unit. The processor has 2 components in it, or 2 major ones. One is the CU, the control unit. The other one is the ALU, which is the arithmetic logic unit. The arithmetic logic unit, just like the name suggests, can do arithmetic and it can do logic. Logic is like selecting things, which is what we're going to do today. And then the arithmetic are things that I'm showing here. Basically, you're making one variable equal to something, or you're doing some kind of an equation, right? These are examples of arithmetic. But let's go to the selection piece, right? ALU and relational operators. Okay, so in here I have some information about first the different data types. I don't know why I threw it in there, but char is 1 byte, integer is 4 bytes, float is 4 bytes, double is 8 bytes, and these are the values that you can represent inside a double and a float variable, right? So this one can hold 7 digits, this one can hold 15 digits, right? So today though, we're going to focus, and I already told you about the arithmetic and logic unit. We're going to talk now first about these relational operators, okay? So the way we check to see if something is true or false and what I'm going to do is I'm going to say this is, I'm going to erase this because what's the point? This is exactly the same as the other one. So I'm going to erase this stuff. And I'm going to erase this stuff here. And the output on the bottom. Alright, fresh start. Okay. So first, relational operators. Paste that. There you go. These are my different relational operators. They're pretty much the same across different programming languages. Double equal checks to see if something is equal, greater than or equal, less than or equal, not equal, less than, greater than. Okay? So these are my relational operators. How do these work? Well, here's some examples. So if I have a cout, 3 is equal to 4, right? And then in here I'm going to do 3 equals 4, okay? And I do endl, okay? And if I run my program, it kind of shows it ugly, so let me do this. No, not there. I'm going to put an is in there. Is, so if I run it, notice what it says. 3 equals 4 is 0. Okay, unlike Python and some other more user-friendly languages, maybe, not sure if Java does the same. I'll try to remember. But in C++, the default for true, so true is 1, false is 0. Okay, so 3 equals 4 is equal to 4 is 0. Is that true or false?
False.
False. Okay, so, and there's ways for you to change this thing. So instead of 1 and 0, it shows you true or false, but I'm not going to do that for now. Okay, and this true false business, all right? True, false is a Boolean data type. What is a Boolean data type? It's something that's either true or false. That's it. Okay? And the way we check to see something, if something is true or false, right? We check to see if something is true or false using these relational operators. Okay? Now, the relational operator is in the middle, and this other thing, the whole thing, is called a condition. Right? 3 equals 4 is a condition, which is check to see if something is true or false. Okay? And generally speaking, the conditions have variables in them, right? So let's say I'm going to have an int x is equal to 3, and I'm going to have an int y is equal to 4, right? Through the two different variables. And then in here, I'm going to do a bunch of conditions just to warm you up. All right, so this one is going to be x is equal to y. All right, this is x, this is y. So let's try to predict the output. What is this going to be? Is this a true or false? 1 or 0? 0, right? False. Okay, if I run it, right, x is equal to y, that's a false. Okay, I'm going to grab this whole thing so I don't have to rewrite things. You have to learn to be kind of lazy when you're a programmer. Not work hard, work smart. So let's do not equal, right? X is not equal to y. Is that true or false? True. All right. False. All right, so that's a 1. Okay, some other ones. Just to give you a taste for this. So x is greater than or equal to y. Is that true? False, right? Is it greater? No. Is it equal? No. So false. Try again. All right, greater than or equal to, false. Let's grab this thing, copy it again. Less than or equal. All right, is that true or false? False. Is x less than y? Is 3 less than 4? Yes, it's not equal, but it's less than. So this is true. Okay, and a good thing for you to do when you're writing your programs is to try to predict what the program is going to show before you even run it. Okay, this is very applicable in bigger scale problems. You're going to have some kind of an idea of how something is supposed to work. You predict a certain way for your program to behave. You write your code according to those predictions, and then you test. Does it really work the way I thought it would? And if it doesn't, then your logic is flawed. Something is not, you didn't write the ifs and else's the right way. Okay? So these are examples of, conditions. All right, I'm not going to do the rest, but you get the idea. There's also less than, greater than. All right, these are your conditions. All right. So, what's up, Jerry?
What up? I thought this was computer science class. I mean, group, club.
No.
Is that not today?
We're not now.
Not now.
Not now. You're welcome to stay if you like. Nice shirt.
I would, thank you. I'm busy. I love coding, obviously. But when is club?
I don't know. We're deciding on the club, and we'll get a mass email out soon. I think they were saying Thursday, or what is this?
They're talking about
Tuesday at 12:50, I think.
Okay.
I'll try to figure out, and I'll send you the information.
All right. See out. I like it.
Yeah.
See out's a good one.
Yeah, that's out. See
That's on
out.
the test, guys.
See out.
All right. See ya.
All right. So, yeah, see out instead of see it. Yeah. I got more of those. I got more where that came from. So, all right. All right. So these are your conditions, and yeah, basically checking to see if something's true or false. Okay. Next is, let's say we have an int age, right? I have some information in there. Go back to this page. Intro to selection. Yeah, there you go. You copy this crap. Okay, so let's say I have this piece of code here, which I have already written. And so I have a variable age, and underneath this thing I have a bunch of different messages, right? So if I run my program, which one of these messages is going to show up? All of them, right? That's just the way we've been doing things. If I run this thing again, right, there it is. It shows you all the different messages. But as you may have guessed, I only want to show one of these messages. Which message do I want to show for this value of age? You over 21, okay? So how do I restrict it to select only one of these messages based on this variable of age? Well, or the value of age. So I do ifs. I go if my age is, this one's for under 18, less than 18, then I'm going to do curly brackets, and inside of the curly brackets is where my cout is going to be. Okay, so if the condition is true, whatever is in the curly brackets under the if will be executed. Okay, so I can have multiple things. I can have you are under quote cout 18 years old, right? I can have multiple things in there. Everything that's inside of the curly brackets will be executed if this condition is true. All right, and similarly, let me take out this one for now. So, and this other one here. All right, let's do the over 21. So I'm going to have if my age is bigger than 21, and this time I'm going to do a single statement. Okay, so I have, this is my statement 1. This one here is statement 2. Question?
Yeah.
What's up?
Can I put more than one conditional?
More than one conditions?
More than one condition in the same condition?
Yes, yes.
Or like if I wanted to do like age divided by 21 is equal to 5 or greater.
Yeah, you can do that. You can do math in there too. That kind of stuff, yeah.
Okay.
Yeah, you can do that. All right, so if you have more than one statements, you need curly brackets for your if. Okay? Statements. Okay? If I have only one statement, statement 1. Okay? So if you have only one statement, the curly brackets are optional. So I can go in there and I can do, all right, curly brackets and then curly brackets, that's okay, but I don't really need them. Okay, if I have a single thing inside underneath the if, it will automatically assume that, well, I don't need the curly brackets. Okay, so be careful. If you have multiple statements that you want it to be part of the if, make sure you include the curly brackets. This is not Python, and C++ doesn't care about indentation at all. You can write the whole C++ program on a single line if you like. It's going to look ugly, but you could do it. Okay, and it's not what you should do. Okay, but there's people that like to do this kind of stuff, you know, just to mess with other people. I'm not one of them. Okay, so if you have one statement, you don't need curly brackets. All right, so let's test this thing with just what I have so far. So I'm going to test this. And by the way, whenever you have a program that has multiple ifs in there, that means the program can go multiple different ways. So it's on you to check if it really works for every possible if. So I got to check to see if it works for this. I got to check to see if it works for this. If I'm going to have 20 ifs, I got to test my program for values that are going to let it go into every one of these different ones. Okay, so that's part of the good testing and why I want you to include how you tested your programs, because I'm not going to do that for you. So let's do, I'm going to do 17, right? So hopefully it shows me this. You're under 18 or whatever. You're under 18 years old. Great. Let me change this program here to 24. I'm going to run it again. And you're over 21 years old. So far so good. Any questions? Still awake? Fantastic. So now let's go to this one. If my age is between one value and another value. So there's two different ways you can do this. I'm going to show you. The first one is the nested if. So let's say if I have my age is greater than 18, curly brackets, and I don't really need to have the curly brackets, but I'm going to throw them in there anyway. Okay?
Are they just required for multi-line?
I'll show you. So, and then I'm going to have another if in there if my age is less than 21. All right? Then I'm going to throw in curly brackets in there also, just because I want to, not because I have to. Throw that in here. Okay? So if age is greater than 18, we're going to go inside these curly brackets. And if my age is less than 21, then we're going to go inside these curly brackets. So if this is true and this is also true, then I'm going to show this message. Right? Let's just test to see if it works. I'm going to go with a value of 19, which is between 18 and 21. I'm going to run it. And your age is between 18 and 21. Works great. Okay? But remember earlier how I told you, if you only have one statement, curly brackets are optional. So how many statements are inside this if? One, only this piece. So that's the only thing that really counts as a statement inside of this one. Now, how many statements do we have inside this one? One, this statement. So that's that line of code. Okay? So if I really wanted to, I can get rid of the curly brackets. Right? And this piece of code is going to work the same way as before. So if I run it again, you're between 18 and 21. Still works. Okay? And I kind of don't like doing this. In fact, actually, this is like the first time I've ever really told people about this stuff. Because as soon as I tell you that you can do this, people start messing up the ifs and the curly brackets, and they start forgetting to put them when they should put them. So if you want to put curly brackets on every if, be my guest. Okay, yes. While you're learning this stuff, whenever you see an if, throw some curly brackets. Okay, unless you think you're comfortable with it, and then you can clean up your code and get rid of the curly brackets. Okay, but I honestly try to avoid telling you this or telling students this so they don't start making unnecessary mistakes early on. Okay, so this is an example of a nested if. Okay, one if inside of another if, which is one if inside of another if. Okay, and now why don't I go and rewrite this thing using something else? So if, so I'm going to do this. I'm going to rewrite the above nested if using logical operator AND. And the AND in C++ is this, unlike in Python. It's the same in Java, it's the same in C. Okay? So, how does it work? I go if my age, and some C++ compilers are really picky about parentheses. So in Python, you can write the whole thing without any parentheses, right? You can just do a condition like just in this. If this was Python, you can just do it like that. And obviously, you can see that C++ doesn't like this by how it's highlighted red on C line. So C++ loves its parentheses. So in here, I'm going to have one set of parentheses for age is greater than 18, another set of parentheses when age is less than 21, and then in the middle, I'm going to have %, okay, which is shift and the number 7 on your keyboard. Okay, and then inside here, I'm just going to grab this piece, copy it, throw it in there. Okay, why don't I throw in some curly brackets? Just to be consistent. Not that you need them for this one. Come on. Okay, so if everything works as expected, this will do the same magic trick as this. So that means that I'm going to get this message 2 times. Your age is between 18 and 21, because I gave it a value of 19, which is between 18 and 21. Run it again, and sure enough, there's 2 messages, right? All right, so this means this here works exactly as a nested if. All right, so, and that brings me to my truth table for an end. Okay, so I'm going to throw that in there using multi-line comments. I don't like how C-line throws extra asterisks in there, but whatever. tab. Okay, so if we want something to happen when both conditions are true, then we use an AND, right? Ampersand, right? And can check if a number is within an acceptable range, just like we did in here. We're trying to see if something is between two sets of values, okay? So if it's between 18 and 21, it's within our acceptable range. The way it works is you have some kind of a condition, right? Like we had the age here, you have some other condition, right? And of course you're gonna have to do some extra parentheses in there. I just didn't put them. So that's your condition 1, that's your condition 2. And the only time that this is going to evaluate to true, the only time this whole thing here, the AND, is going to evaluate to true is if we have two truths. Okay, if you have a true and a true, the AND evaluates to true. If you have a false and a true, then it evaluates to false. If you have a true and a false, it evaluates to false. If you have a false and a false, it evaluates to false. So if you have one false in there or two falses, the whole thing is false. You need to have both of them true in order for this thing to be true. Okay, that's your truth table for an AND. And again, it's other than using it logically, like an AND, the way you would think with, you know, about things logically. Like I'm trying to open the door, I'm going to grab the handle and I'm going to rotate it and I'm going to push it. And if it's not unlocked, it will open, right? You write that, you know, that's how you write the code in your programs. Okay, and it actually teaches you how to think about life in different ways. Okay, this kind of, you know, algorithmic approach of thinking out about problems really helps. Okay, for me at least. So that's an AND. Now let's do the invalid age business, the fun part. So I'm going to do this. I'm going to go all the way to the beginning and I'm going to throw in invalid age first. Okay, so let's decide on what is an invalid age. Negative number, right? Negative number is an invalid age. So I'm going to say if age is what? Less than what? Well, let's go with less than 0 because 0, I don't know if that counts as negative. Right? So if age is less than 0, I'm going to tell you that's an invalid age. Okay? And now when I run my program, what message am I going to get? What's that? It's invalid age. Any other messages? Huh? You're under 18. Why? Because if I have a negative value here, this is negative 19. Is it less than 0? Sure it is. Invalid age. But then is negative 19 also less than 18? Yeah. So I'm also going to get this error message. Or not error message, but this message. So if I run my program, this is an invalid age, and also you're under 18 years old. Okay, so what I'm trying to do is, I'm going for just the error message. This is an invalid age. And if that thing is true, I don't want any of the other things to happen. Okay, so how do I make that happen? I turn this into else ifs. Okay, so C++ is a little less lazy as far as typing is concerned than Python. Question?
I was wondering why you split the you are under 18 years old.
I just broke it. Why did I split this into two pieces? So that I can illustrate the example that if you have two lines of code, you need the curly brackets, but if you have one line of code, you don't need the curly brackets.
Okay.
Yeah, that was the reason.
Alright,
Yeah. Yep. Okay. So now if I run my program, I have an if, I have an else if, and I have an else if, right? So how does the else if work? Let me put a little comment in here. Why is this off? I don't know. So else if only gets checked when the previous if or else if was false. That's it, right? So if this thing was true, All right. I don't know why it's doing this. If the previous, okay, when the previous if or else if is true, sorry. Yeah, when it's true, the else if does not get checked. Okay? So it's basically another way to, it is a way for my program to stop at the first thing that is true. Okay? So if, else, if chain is a way to stop your program at the first thing that is true. Okay, so whichever one of these turns out to be true first, we stop there. Okay, you might have a million lines of code after the first if. You don't want to go and waste the processor's time to think about these things if some condition isn't true, right? So you're saving the processor from thinking about too many different things, and you're also limiting the behavior of your program in a certain way, right? So there you go. This is an invalid age. All right, so why don't we go with another, what else would be a bad age? All right? Huh? Well, I guess you could say we have some kind of a 2.5 years or whatever. So yeah, good point. You shouldn't have a decimal for this, but let's just say that you could have a decimal. Well, like for a human being, what is the max age we're going to go with? Huh? 100 something? All right. Well, that's the fun part. All right. Let's do this, and let's do this. Let's Google the oldest human being. Oldest human being. All right. And the oldest human being turns out to be this lady right here, Jeanne Calment, which is some French lady who lived 122 years and 164 days. Right. There's some other people out there that claim to be old or whatever, but we haven't really found the birth certificates of them. Like, we don't have the birth certificate of Moses, right? Even though supposedly he lived 1,000,000 years or whatever that was. Okay? So, the interesting thing about this lady, though, is what do you think she did until she was 119? What healthy habit do you think allowed her to live that long? Huh? She's French, yeah. Huh?
So I'm guessing she smokes cigarettes and she's French.
Good guess.
I'm guessing she
Good,
drinks wine.
good guess too. Glass of wine and a cigarette. Yeah, she smoked cigarettes. And
Actually?
yes, that's her right here.
Oh shit. Well, there we go.
That is the oldest documented human being in history. You're welcome. Now you know. Okay? So now you know the key to longevity.
So 122.
122 and a half, and she smoked every day. The reason she stopped smoking at 119 is because she was sick and tired of asking people to light up her cigarettes. She was blind at that point. And she just, not for health concerns or whatever, but she stopped smoking, and then 3 years later she died. Anyway, but she also drank a bunch of wine every day. She ate tons of chocolate when she got her hands on it, right? I think she was like riding a bicycle until she was 100 and something, and then fell down and broke her hip, and then stopped, that kind of stuff, right? But now you know. Yeah, they've been lying to you, all right? Smoke every day. So, just kidding. All right, so Jean Calment lived to 122 and a half, so for our program's sake, all right, let's say that no value over 123 is acceptable. Okay, so I'm going to go in there, and I'm going to say, all right, if my age is greater than 123, I'm going to say that this is also an invalid age. There you go. All right, so let's go and mess with this thing. I'm going to go give it a big number like 199. Okay, run it. And this is an invalid age. Make sense? All right. So, but notice that I did. And by the way, I could have done an else if I wanted to, right? Because if the value is less than 0, why am I even going to bother check if it's bigger than 123? Why am I going to waste the processor's time to think about these things? So, but notice that I wrote the same cout 2 times. All right. So what I'm going to do next is I am going to rewrite. Man, I hate it when it does this. So I'm going to rewrite the above if else if using an or. Okay, and the way we do or in C++ or C or Java is with 2 vertical lines. Vertical line, vertical line. And these are shift and the number right on top of your enter key. Right? The one that's the backslash. You press shift, you press that number, that key, that's the or. So what I'm going to do is I'm going to do if, just like I did with the end, right? C++ loves its parentheses, so I'm going to say age is less than 0. Then there's an or in the middle, and my age is greater than 123. And if this happens to be true, I do this message. Okay, I'm going to go in there. I'm going to turn off this piece of code, or the two ifs, else ifs on top. I'm going to test my program again. So I'm supposed to get the same. This is an invalid age because I'm testing it for 199. Test. This is an invalid age. Okay, I'm going to give it a negative 199. Test. This is an invalid age. So you can see that the or that I wrote here works the same way as these 2 separate ones. Okay, and I have in there on the class web page, I have a little truth table for the or also. I'm going to copy this and I'm going to write it here somewhere. Finally fixed. Using a multi-line comment, paste, tab all that stuff in there. Okay, so if we want something to happen when either one or both of the conditions are true, then we use an or. Right? Or is 2 vertical lines, right? And or can check if a number is outside of an acceptable range. So in this particular case, we're checking to see if something is outside of my acceptable range between 0 and 123. If it's less than 0, bad. If it's greater than 123, bad. Okay. The way an or works is you have some kind of a condition, you have another kind of a condition, or 2 different conditions, and the arrangement of things is either true, true, false, true, true, false, false, false. Okay, and this is different from how the AND works, right? This one is going to be true for all these different ones, right? The only time an or is false is when both of the conditions are false. Okay? Any questions? So now you know about the 2 logical operators, the or and the AND. You learned about ifs and elses. Ifs and else ifs. You learned about the relational operators, right? All these here, which is how we build conditions, right? Which is checking to see if something's true or false. And then what else? What else? What else do I want to tell you? I guess I want to tell you about the else. All right, so I'm going to throw that in here. So let's say I have a variable num, right? And then I have num is equal to, I don't know, 10. Okay, I'm going to have an if my num is bigger than 0. I'm going to have a message cout num is positive. Okay, and then what I'm going to do is I'm going to have an else, and then I'm going to have a cout. And why don't I throw in the curly brackets not to confuse you? All right, let's stay with the consistent things, even though you can clean up the code a little. All right, else curly bracket. Throw that in there. Okay, this time I'm going to say let's say greater than or equal to 0. This one here is going to be negative. Okay, so how does the else work? The else automatically happens when the previous if or else if is false. And I guess I should have broken down into a little extra piece. So if it's greater than 0, it's positive. And if my num is equal to 0, I'll tell you this, and I guess throw in some curly brackets in there. Condition is always false. Really? How is that always false? Sometimes C-line thinks it's smarter than this, but it isn't. Okay, else if. Why is it always false? Oh, we'll find out. Huh. Unreachable code. Oh yeah, it's always false because this starts at 10. Whatever. Okay. If C-line gets too invasive, tells you too many things, sometimes it's better to ignore it. So anyway, what I'm going to do is I'm going to test it with a 10. So it should show me positive. Then I'm going to test it with a 0. It should show me this. And then I'm finally going to test it with this, and it's going to show me negative. Okay? So the else gets checked when the previous if or else if is false, right? Which is different from how the else works, which is it automatically happens when the previous thing is false. Okay, it does not have a condition. The else does not have a condition. Okay, so write this, run it, and 10 is positive. Okay, I'm going to make it a 0 now. Okay, now it's a 0. Still think it's false? I guess thinks that 0 is... That doesn't even make sense. Yeah, why does it think that this is positive? Yes? I guess it thinks that 0 is positive. Let's try 0 here and greater here. No, it still doesn't think it's true. So I guess C++, yeah, this doesn't make sense. I guess my example is going to hell right now. So let's do this. Well, this worked perfectly when I did it for the Python language. But for some reason, C++ is acting stupid. So what I'm going to do is this. I'm going to get rid of the 0 altogether. Alright. This is the greater than or equal. There you go. So I can illustrate how the else works. So if this thing is now a negative 10, alright, then this is a negative. There you go, negative 10. 10 is negative. Okay? So yeah, C++ is not my favorite language because there's things like that happen, pop out of nowhere, and then this is not even the, this is not the tip of the iceberg, or this is the tip of the iceberg. There's a lot of other things that can go wrong with C++. Okay? But let's keep it positive for now. So that's an example of an if and else. So the else only happens when the previous thing is false. It does not have a condition. That's it. Okay, so now you know what's an if, what's an else if, what's an else. Okay. What else do I want to tell you? So there's the possible different scenarios that you could have, right? Some of these I already showed you. You can have an if, right? You don't need the curly brackets for it. If you have a single statement, you can have an if inside of another if. I forgot to put the parentheses in here, right? You have to have parentheses in C++. You can have an if with an and in there, two conditions, other than, instead of using the nested ifs, you can have an or, right? You can have one condition and another condition. You can have multiple ifs. You can have an if. It doesn't have to be if, else, right? You could have an if, else if you like. That's fine. the else, you can only have one else at the end of your if-else chain. Okay, this if-else chain, remember, is just a way for the computer to stop at the first thing that's true. And you can also have an if, else if, else if. You don't have to end it with an else at the end. Okay, you can have an if and just an else, like I showed you. That works too. Some of the common mistakes are having an else just by itself. You can't just have an else. You need to have an if or an else if before it. Same way, you can't just start with an else if. You need to have an if before it. You also cannot have a condition for your else, right? Else does not have a condition. There's nothing in it. It happens automatically when the previous thing is false. And another common mistake is having an single equal sign. Okay, and unlike Python, which will give you an error message, if you do this kind of stuff in C++, the program will just run and it won't work correctly. Okay, if this was Python or some other more higher level language, it will give you an error message. Yes?
So it wouldn't tell you the syntax error?
Nope. Let's try it. So I'm going to go in there. I'm going to say, all right, num equals 0. Just like that. And that's not what I had before, just in case you're wondering. All right, so if I have a single equal, no, there's no error. Always negative. So I just ran. All right? It's just stupid, yeah. Try this. Make it a 0. And now it's not going to work. Oh, now it still thinks it's a negative. Welcome to the C++, folks. That's how it works. Okay? It works all the time, 90% of the time. Okay? So the moral of the story is don't use a single equal instead of a double equal, right? And I'm not sure why it's messing up like this. It really doesn't make sense. I gotta go play with it some more later. I thought I had a good example going, but it does not work in C++. Anyway, so don't use single equal sign, right? Single equal is the assignment operator, okay? Another thing, if you have an if, so let's say, remember here, where is this thing? Here, right? We have an else if, right? Which is okay. It's okay to have an else if here because we had another thing before it, right? Else if age is greater than 18. If I try to do an else if here, that's no good, right? Notice it kind of highlights it in red. What is it saying? It's saying else without an if. That's a C-line error message. Let's see if I get the same error message from the compiler. This is the actual error message that you would get from the C++ compiler. All right, so C-line actually gives you more meaningful error messages than the default C++ compiler, which is not the same how Java works. Java will give you the same error message in here in the IDE that you would get in the command line. C++ is not that user-friendly. Okay, but anyway, you can still figure out that, oh wait, it's pointing right here to the else, and it's telling you expected expression. Okay, so all it really is basically you have an else without an if, which is what C-line tells you. Okay, so I highly encourage you to use C-line if you want to, but you can write your code and whatever else too. Okay, so bottom line is you cannot start with an else if inside of the curly brackets of an else if or an ifs. Okay, you have to start with an if. If has to be first. Just like we had an if here first, right? You cannot start with an else if, right? You cannot have an else with a condition. So these are some of the common error messages. Okay, so those are some of the things that I wanted to tell you. Pretty much those are the things that I wanted to tell you. Oh, and there's like how to show true and false instead of 1 and 0. I threw it in there. All right, so what do we do? Let me fix it. Let me go fix my code. So I already said that 1 is true, 0 is false, right? What I'm going to do is I'm going to use this piece of code right here. So I'm going to say, all right, I'm going to say cout, whoops, not comment, cout dot setf std iOS bool, come on, iOS bool alpha, right? And if you've played around with Python a little bit, you can see how less user-friendly this language is already. Just for me to show the true and false, I gotta jump through a bunch of hoops. That's just how the language is. Okay, it's an old language. This is one of the first programming languages, or based on this language, a lot of other later programming languages were derived. C#, Java. There's a whole bunch of other ones. Visual C++, right? So let's hope this works. Hopefully now I'm gonna see trues and falses here and there. Run it again. And there you go. Now you can see true and false, right? So if you want the C++ programs to show you true and false, need this to show true, false. Otherwise, it shows 1 and 0. Okay? All right. So that's done. Now we know all of it. Relational operators, conditions, logical operators, and now let's go through these different assignments so I can give you some clues and hints. Okay, so first one does not really require a hint. You basically type all this stuff up, including the comments. The comments explain to you what's what, so that when you look at your old code or you look at your first programs, you know how things are working. Okay, so type this whole thing up, get it to work, test it. Put the test at the bottom of your code. We're using multi-line comments. Don't forget to put, the comments on top, the program number, the date, all that good stuff, right? Program numbers change. It used to be a different example, so change it to what it is this. Next one, height message. You have some kind of a clues in there? No, not really. Okay, so we have a given problem. Write the following program to compute a person's height and print out the message. The user will input feet and inches. The program will convert that to inches, then print a message based on the total inches. Like if you're 72 or higher, you're tall. If you're between 5 and 6, you're average, I guess. And if you're less than 60, you're vertically challenged. Question? Whatever shaming message you want. Yeah.
Is there a way to combine the C out and C in so that I have a prompt on the C in?
No.
I have to have.
You have to have a C out and then a C in. If you want a prompt, this ain't Python. No. Yeah. C out is your prompt, C in is your input. That's it. Okay. All right. So how are we going to do this? Let's go to this thing here. So I'm going to go to the bottom, and we're going to do hint P8. P8 hint. All right, so I have, what are they? It doesn't say what they are. Okay, I'm going to say they're both floats, right? Float, feet, and inches. I'm declaring two variables on the same line. Cout, enter feet. All right, cin, feet, cout, enter inches, cin, inches. Okay, and then I guess maybe I should have another variable called total inches. Okay, and then I'm gonna do some kind of a math, like total inches equals feet times 12 plus inches. Okay, and then I got to do some ifs and elses. So if my total inches is greater than 72, I told them cout, you're tall. Huh? Yeah, how's the weather up there or something, or you're too tall. There you go. You have to shame the user. You're too tall. Okay. Yeah. And then if or else if my total inches is less than, it was between 5 feet and 6 feet. All right. So what's 5 feet in inches? 60. All right. It would be so much easier if you guys were using the metric system. I feel sorry for you. All right, but whatever. How many feet are in a mile?
A lot.
Five.
Isn't it like 2,500?
5,280.
5,000.
I only know that because I did engineering and we had to do a whole bunch of that until it sunk in. Right? Anyway, same thing with your, whatever. Yeah, like all your systems are off. Like the rest of the world is better. So anyway, 5 is 60, 6 is 72. All right, so if this thing is less, if it's greater than or equal to 60, and my total inches are less than or equal to 72, then I guess you tell them they're average, right? So yeah, you are just average. You are just average. All right, and then do a similar thing for the last one. All right, do the last yourself. I already gave you more than enough. Okay, and then one thing is, try to not use the hints unless you absolutely get stuck on the problems. Okay, because I provide too much help. It is actually better for you to hit the wall and kind of get stuck and try to figure these things out on your own than to just follow somebody's solution. Okay, so try to only look at my hints if you really have to, if you get stuck on things. Okay, but if you do have to look at them, look at them. All right, so that's the P8 hint. All right, I guess I can test it. I should test it, maybe. All right, so enter feet, I don't know, 7 feet, inches, 9 inches, and you're too tall. There you go. And again, you have to test it for the other one, and then you have to test it for the third one. Okay, so that's the P8. I'm going to comment all this stuff out. Okay, let's go look at the P9. P9 is the letter grades. Okay, so the letter grades goes like this. So this is P9 hint, P9 hint. All right, so you're gonna have the user enter some kind of a grade, percent. So we're gonna have, let's say, all right, float, percent. Okay, C out, please enter percent. CN, percent. Okay, and then based on this thing, we're going to give the user some kind of an error message or some kind of a message. So if my percent is less than 0 or my percent is bigger than 123, okay, I am going to give an error message like cout invalid percent. Okay? Then if I have another one, else if my percent is bigger than or equal to 90 and my percent is less than or equal to 100, then I'm going to give another one. You have an A. Okay, and if you want to show the quotes inside here, you do backslash quotes, backslash quotes. That way you show the A around A surrounded by quotes, and you do the rest. Do the rest of the grades. All right, B, C, D, F. I don't know why there's no E. Okay, so that's that. The next one is P10. P10, precision, area, perimeter. Okay, write a program which asks the user to enter the width and the height of a rectangle and then calculates and shows the area and perimeter of the shape, rounded to 1 decimal. Validate user input. Make sure that the error message shows if either width or height are less than or equal to 0. Okay, so validating user input, something I gotta show you. Check something real quick. All right, I got 3 minutes left. I'm almost done. All right, so validating the user input. Validate P p10 hint validate user input. Okay, so we're gonna have two, what do we have? Width and height. So let's go with ints, width and length. Width and height, okay, whatever. Height, okay, and we're gonna say cout, please enter width, okay, cin width, all right, do the same for height, all right, input, and then we're gonna do if my width is less than or equal to 0, or my height is less than or equal to 0, then I'm going to go and give an error message. All right, something like invalid input for width or height. Okay, and then else, then calculate and show area or whatever we're doing, area and perimeter. Okay, how we're going to do this? In here, I show you how to round things. I'm running out of time, so I'm not going to show you how to do this, but you basically do cout set f ios fixed, cout set f ios show point, and then cout.precision, and then now you'll be able to round the numbers to 1 decimal. Okay, so that's your hint for the rounding. Okay, you can do the rest. So I'll leave this here. All right. Oops. Is that the one? IO precisions, quarters, nickels. Write a program that allows the user to enter a number of quarters, dimes, and nickels, and then outputs the monetary value of the coins and cents. Validate the user input. So basically, the user enters all these different things. You're going to validate. So this is P10, P11 hint, right? You know how to validate input. You're going to do this kind of a business. So if any of the values are less than 0, give them an error message. Otherwise, calculate what the value of things are, right? So all you have to do is, let's do one more. So P12 hint. Okay, so P12 hint is basically you have, let's do int, quarters, pennies, nickels, dimes, right? And you're going to have also a total. Total is going to be equal to, you have to do user input. User input. All right, the total is going to be equal to quarters times 25 plus nickels times, or let's do dimes times 10 plus nickels times 5 plus pennies, and that's it. Okay, that's what you have to calculate, and you have to do validated user input. Okay, so that's the 12, and I'm done, I promise. One last one. I gotta give the clues to all of them, otherwise I can't sleep at night. All right, 13, I'm just kidding, I can sleep like a baby. All right, so compute distance, write a program that allows the user to enter time in seconds. Your program validates the user input, so make sure the time is positive, okay, or equal to 0, so that if the user enters a negative value of time, then the error message shows up. The program calculates the distance, all right? So this is your P13 hint, all right? So you have int time or whatever, you have user input, right? Validate input, and then you have distance. Let's do a distance in there too. Distance is, what the hell, I'll make them doubles. All right, and then the distance is equal to your, here's your formula, acceleration. We're assuming acceleration to be 32. And let's go with 32.2 because that's what it really is, times time squared. We can't really do this in C++ or most programming languages, so to keep it simple, just do this. Times times time. And that's it. Oh, and then divide the whole thing by 2. Alright? That's the projectile formula or whatever. Okay, and there you go. So those are all your hints. You also have to do a little homework from Chapter 1 Savage, which was from the previous weeks, in there somewhere. Alright, in one of the PowerPoints, right here. Chapter 1 Savage, you have a quiz that goes with that. And that's all I have for today. Okay? Thanks for coming. I will post this for you. Question?
Super quick, can you show me how to append a variable?
Append the variable? What do you mean?
Like append the value?
That's, we've been doing that. We did like, for example, cout time equals time.
No, I want to append it. I want to add to it.
Oh, add to the value of the variable?
Like, I have a variable like 1,
Uh-huh.
and I want to run it through something and then say, okay, now it's 1 and this, and append it.
You
It
mean,
would be like Python, I'd be dot append.
oh, you can't. That's for lists and stuff like that. Yeah, appending things is for lists in Python.
Well, I want to do like a text, like a string.
You trying to append to a string? Then you just
do
do.
the convert binary by dividing it. So every time is it divisible by 256? If it's greater than 1, append it with a 1, otherwise append it with a 0. Is it?
String manipulations are not pretty in C++. There's no easy answer. Yeah. We can look at it, we can play around with it, but generally I stay away from strings in this class. Yeah.
I don't like this.
I don't either. I don't either.
Thought I was gonna like it.
Yeah,
I'm
C-
like,
I'm surprised we don't use system.out.print for
what's that?
creating statements. Usually I use system.out.